Thanks everyone for coming. I'm Alex from tutorial.com. Got my colleagues here, Milan and Petar. Petar is somewhere around. Here with us today are Nick, Andy, and Alex from Unity. And I will, briefly just say thanks to ICT Hub for letting us use their space here again. We are a resident team here. Our tutorial.com startup is all about connecting game makers, and this is our third offline connecting game makers here. And we'll be talking about Unity 5, which is obviously the new and the best engine out there. So yeah, thanks for coming. Hopefully you guys will go and check out tutorial.com, show us some love and support. And thank you, Maya. Thank you, Level Up. You guys are the best, and without you, none of this would be possible. So, without further ado, Andy, you can start.
Okay, so we'd also like to say thanks to Alex, Petar, and Milan, ICT Hub, for hosting this. These guys have done a really great job. Communication has been fantastic and allowed us to do this event very well. And also thank you to everyone for coming in the evening, especially after a day of work. So really happy to see so many people here. So Alex and I are going to keep it brief because the main presentation is Andy. He's got the really interesting stuff. So brief introductions. My name's Nick Jovic. I came to Belgrade last year for Casual Connect, and we met a lot of developers, and we've come here this week to meet more customers and also visit education, and it's been a great 2 days. I look after sales and business development in Central Europe, includes this region, all the way up to the Nordics. So if you have any questions about licensing, support, anything of that type, then I'll be happy to help.
So similar to Nick, I've worked alongside Nick on the business development team. It's looking after a lot of the kind of small studios and startups as well, and the growing studios in the region, but also the educational sector. So any queries about that, if you're interested in using Unity, we've dropped our business cards up there, so go and grab one, send me an email. I'd love to hear what you're doing, and if you want to try out Unity, I'll be on hand to help.
If you listen very carefully to the presentation, we're going to be asking questions at the end because we'll have some t-shirts as prizes, so make sure you listen.
Unfortunately, I don't think I can actually enter that competition, but yeah, I'll try it. Hi, thanks for coming along. Unfortunately, I don't know any Serbian, so I'll be doing this whole presentation in English. I know 2 words in Serbian, which everyone said I need to get by. Vala? Okay, Vala. And is it Biro?
Vivo.
Yeah. Yeah. So that's all you need to know. There, I'm done. So this presentation is going to be in English. I'm going to have a couple of slides, and then what I'm going to do is I'm going to spend most of this presentation in Unity building something from scratch. So I'm going to have absolutely nothing, and I'm going to build in assets, physics, have all sorts of crazy stuff going on. This presentation is very hands-on, and that has some slides towards the end. I don't like PowerPoint, funnily enough. So that's as an introduction. So this is me. So that's me cosplaying as Mario as a baby. I showed this image to someone from Intel, and they said they still program on that keyboard. So by that you can guess how old I am. So I'm a Unity evangelist. That's actually a really difficult thing to describe. My family assume I'm a Scientologist like Tom Cruise, and that I do all sorts of stunts in Dubai. That's unfortunately not what I do. I basically go out to the community, present Unity, show off Unity, train people into Unity. I've presented on a boat, on a train, wherever it is, in a gym, in an elevator, basically wherever people are happy to listen to how they can use Unity to make games, installations, VR, UI, basically anything they want. I've seen some very strange projects with Unity, which is amazing. So hopefully by the end of today, I'm going to show you a lot of bits and pieces which you can actually just go away after the presentation and do yourself, because all the assets I'm going to use are free to use, and I'll put up some links at the end. So yes, Unity evangelist. So I'm actually luckily, I'm really into games as well. So if you are making a great game, or you have ideas for a game, or you've shipped a great game and you'd like someone from Unity to try it out or sort of understand it, or kind of have a look at your game and things like that, or maybe suggest, oh, we're releasing this new feature soon, like perhaps you'd be interested in this. Send me games. I have a Twitter account. It's not like an official corporate Twitter account. I just talk about the weather, and as it's really bad in the UK, so I'm very happy to come to Serbia, and it's very nice and beautiful. Too nice, and I have to go back to the cold. So typical Britishman, typical Englishman. And I have an email as well. Feel free to send me that. Say hi and just chat. Groovy. So every time I do a presentation, I like to find out a bit more about the people I'm talking to. So put your hand up if you're a programmer, a scriptwriter, or like copy-paste code from online, stuff like that. Wow, okay, just about everyone. So everyone's copy-pasting. Okay, cool. So put your hand up if you're a 3D artist. Okay, there's the 3D artists over there. Okay, that's cool, in a little group. Put your hands up if you're a 2D artist. Okay, the same people. Okay, that's pretty cool. Put your hand up if you work in audio, so you create music and things. The gentleman is a bit, so every time I ask that, someone always puts their hands up, and they always have a beard, and they're normally in a band. Are you in a band? They're normally the drummer in a band. It seems to 95% of the time that always takes place. Okay, put your hand up if you work in QA, so quality assurance and testing. Technically, everyone should put their hands up, but okay. Put your hand up if you're a game designer, so it's kind of your job to annoy everyone. Okay, cool, cool. Okay, sweet. Put your hand up if you use Unity. That's generally a... Okay, put your hand up if you have no idea what video games are, no idea what Unity is, you just saw a bunch of people in a room and thought this might be pretty cool. Okay, yeah, and the gentleman at the back. Okay, hopefully you'll go away wanting to make video games. Cool. Awesome. Put your hand up if you're from Serbia. Put your hand up if you're not from Serbia. Yeah, one person. Nick left already. Groovy. So I'm going to give a little bit of history. So we're at Unity Technologies. We have kind of two goals, and they're super ambitious goals. We're going to democratize game development, which is actually a really difficult thing to do. And what we wanted to do is we wanted to bring tools that were flexible to make anything you wanted to make. I've seen like a dolphin simulator where you wear an Oculus Rift, you have to cheat in an exam by looking at other dolphins' test papers. Yeah, stuff like that. Basically make any Hearthstone, Rust, have a bunch of naked dudes spearing each other with spears. Basically sort of make any game. So anyone can pick up Unity and make any game. It doesn't have to fit into a type of genre, a style, visual quality. So that was kind of our first goal. We kind of have a new goal now, and that's to help developers to create, connect, and succeed. And that kind of doesn't make sense to begin with, but at the end of this presentation it will. So we want to help developers to create the content, produce tools that basically you can use, customize, make amazing things and have fun with them, and create great projects. And then the last bit's the connect bit, which I'll talk about at the end. So that's not only after making your game, but actually releasing your game and then allowing your users to either share your game via social media, connect with them, understand if they're 100% of your users are failing the tutorial, for example, and basically trying to connect with your users to understand how you can make your game better and be better game developers. So we want to solve one, and we want to solve the other, and then hopefully you succeed and have fun and make loads of money. That's pretty cool. So we make a whole bunch of things. So we make the Unity game engine, which is the thing we've been doing for the last 12 years or so. And we've now started to make other areas. I'm going to talk about these areas later on, but these areas tackle sort of lots of problems in making games. So cloud build is a method of building your games automatically, testing them automatically, and then distributing them online. So I could build my game as an Android application and post a link on Twitter and have everyone on Twitter download my game and tell me what it's like. Analytics allows you to compare games across all regions, locations, and things like that. Ads is if you want to display video ads to make loads of money. Like the team who made Crossy Road made is it $5 million from video ads, which is lunacy. And every player is sort of a method of recording gameplay and then sharing it via Twitter, Facebook, YouTube, whatever it is. So I'll be talking about those other things later on, but I'm going to do most of it about game engine and then how the other things tie into it. Great. So we released a new version of Unity, Unity 5, and in Unity 5 we've done a lot of changes. A lot of these changes are to do with both visual tools, so basically creating things that allow you to make things look amazing but also customizable. We've done a lot of changes in terms of audio, so we now have a new full audio mixing system, which I should have time to show off. We've got lots of changes in optimization, such as physics are now super optimized, and I'm going to show a scene of thousands of cubes bouncing everywhere and my character running around and the frame rate's not dropping, which is pretty cool. We've got new changes in terms of build targets, so we now support WebGL. We also now support the new 3DS as well, and I think we're the only middleware provider other than Nintendo's own frameworks that support the 3DS, which is pretty cool. And we support a whole bunch of things. I'm actually going to do most of this next bit in editor, hopefully. Cool. So a brand new scene in Unity. So when you open up Unity 5, you start off with a really simple scene like this. So the scene has a skybox in the background of a sky, which we can swap out whenever we want. We also have a light that's basically being positioned like so. And then we have also our workspace to work in. So I'm going to build up bits and pieces slowly. So I already have a kind of environment. So if I go down and bring in this atrium. Okay. So I've got this big atrium environment, and I can basically zoom into this atrium. So this is an atrium from an actual game made with Unity. So if I go back to here, we have our Unity 5 showcase of all the games made with Unity 5. So we've got this super nice spaceship game, which looks all nice. A forest, if you want to go for a nice walk. So do some arrows. Some Warhammer things. This beautiful game, Republic. Final Fantasy. So yeah, I've got this environment. Oh, hang on. So I've got this environment here. So we have this environment with the characters, the statues, and this is environment with reflectiveness, lights, and sort of like all sorts of bits and pieces. So we worked with Camouflage quite closely, and they've actually now taken these assets and put them on the asset store. So you can now download these assets and see how they're built up and constructed. So everything I'm going to use is actually assets from a game made with Unity and already shipped, which is pretty cool. So I've got this environment here. Now, the downside with this environment is a couple of things. So, for example, we have this environment here. We've got these statues that are standing there, like so. We've got the floor. And everything has a really nice blue hue. And that's because when you bring anything into Unity 5, it automatically uses the coloring of the skybox. Now, there's a couple of reasons for that. The first reason is lighting in Unity 4 was very flat and very solid. And what we wanted to do is we wanted to have nice lighting that basically illuminated the whole environment. So, global illumination. We wanted everything to look really nice, make sure all these different pieces looked really nice in the scene. However, it doesn't really make sense, this lighting, because if we look inside here, you can see we have all sorts of weird lighting. We've got some weird lights here, where instead what we want to do is we want to place a light in the center of the room and then have it all lit up. So what we're going to do now is we're going to select our environment, and I'm going to go to the top, and I'm going to toggle on light map. So the way that Unity lighting works is you set which objects you want to be affected by global illumination, and then it will bake it in the editor. So whilst it's baking it, you can do other things. It kind of is like a loading bar in the background. So put your hand up if you used After Effects. Okay, so you know when you apply effect and then you have to like render it in or bake it in. It's kind of similar to that. But then after you've baked it, you don't need to change it. You don't need to play around with it. It kind of does a mini bake in the background of how your real-time lighting is going to look. So what we can do here is in the lighting panel, we can play around with lots of properties. So I'm not going to use any baked GI. All lighting in this environment is going to be real time. So I can have a light moving around. It's going to have nice bounces and nice sort of lighting. I'm going to set my CPU usage to be, I've never actually selected unlimited, so I have no idea what it does. But that sounds very worrying. But I'm just going to set it to high. And that should be fine. So if I select my environment, so I've got my whole environment selected, I'm then going to go to my inspector. I'm going to go here and set light map static, and it says yes, change children. Now what you'll see is in the bottom right hand corner, there'll now be loading bars loading in the background in Unity. So it's basically baking this in the background. Now previously in Unity 4 and previous version of Unity, if you were to do this, there would be like a big loading bar in the middle, and then you go away, watch Breaking Bad, go to the cinema. I actually did that once, set off a bake, went to the cinema, and then came back and it was still baking. And kind of, you'd have no concept. So whilst we change this, so whilst it's baking in the background, you can actually still do stuff in the editor. It just kind of catches up with it. So whilst it's baking in the background, I can actually continue to build up my game, place UI items, write some code, do some scripting, do some animation in the editor whilst it's baking in the background. So it's actually really nice workflow, in that it's actually calculating sort of real-time GI, but it doesn't block you. You're not having to stop every 5 seconds for a big loading bar. So this scene sort of takes about 4 minutes. So whilst it's doing that in the background, I can actually do other bits and pieces. So for this, I'm going to talk about PBR. So whilst that lighting is baking in the background, and yeah, it takes about 4 or 5 minutes, I'm going to talk about physically based rendering. So whilst we have the lighting baking, after it kicks in, it'll look badass.
So what we have here is we have a character. Let me rotate him around. So we have a really nice character, and he's very simple, and he's called Evan. So Evan basically is a robot that I use for all sorts of demos, and he has a skeleton, he has a mesh, and he runs around. But the other great thing about Evan is he's actually just one big mesh with one material. So he's really, really optimized. So what we wanted to do with Unity 5 is out-of-the-box resources, make things look really, really nice straight away. You don't have to invest a lot of time and a lot of effort into actually creating things looking really nice. We basically have a nice shader called so it was originally called the Uber shader, and then it was changed to the universal shader, and now the standard shader. Personally, I preferred Uber, and I think just before ship day, I wanted to go into the source code and change it, but they didn't let me. Cool. That's my work calling me up. That's okay. So what we have here is with Evan is he looks very grey and sort of really bland. And what we can do here is we can, hang on, let me rotate him around a little bit. Eventually he'll be running around, jumping, doing all sorts. So with Evan, we can see here that the default sort of shader in Unity is much better than one in Unity 4 because it has some nice highlights, he has some nice specular, we've got some sort of nice sort of shadows around here. As you can see, the lighting is still baked in the background, so I'm still able to bring in characters and do all sorts of other things. And what we can see here is the standard shader, or this physically based rendering shader, has been made as simple as possible, but as extensible as possible. If you don't think it does something you want it to do, you can have the source code. So we have the source code for this shader or elsewhere thing on our GitHub. And basically you can take that and you can modify it. People have already modified it drastically, and it's into water and all sorts. So the way that this shader works is you plug in certain values. So by default, you have a default texture value. So someone give me a color. Orange. Yeah, I had blue, orange, pink. So that's kind of red. Someone normally says white. Someone normally says black. So was it orange, someone said? So what you can see here is he's kind of default plasticky because the lighting is affecting him like so. He also has, if you notice here, he also has an element of how metallic the object is, but also how smooth he is. So you could have something super metallic, say a car, but if the car's rusty, it's not going to be as smooth. So you can kind of combine both the metallic workflow that you would use in Substance Painter or in Maya and things like that, and basically apply that into Unity. So we have actually everything in this environment. Oh, that's now baked, but I'll play around with that in a bit. So everything's environment actually uses this same shader. So you can have the same shader on thousands and thousands of objects, all sort of like tweaked for plants and things like that. So now that we've got a character like so, I've got a couple of textures that I can apply to him. So let's have a look at the textures. Materials. So I have my base texture. So I've got my map like that. So let's apply that. So he's now kind of like orangey tint. You'll notice he's got sort of a nice specular highlight, and that's partly because our PBR workflow actually is based on the Pixar's PBR workflow. Because Pixar, come on, who doesn't like Pixar? Okay, you all like Pixar. So Pixar actually do really nice sort of like PBR or physically based rendering workflow, and they talk a lot about how they create that. So we decided to kind of base ours on theirs, which has proved pretty amazing. So what we can actually do is we can actually tone up the smoothness of our character. So our character's now really, really smooth. For example, if I took away everything and I sort of set him to be, that's as smooth as you could get. He's actually reflecting the skybox in the environment. So you can go from no smoothness, so let's say grass isn't that smooth, I don't think, to say a mirror. So you can define how smooth it is. And the reason why I did that is every object kind of in the physical world, or the physically based physical world, has an element of smoothness. So this chair is smooth to an extent, and it's metallic to an extent. Grass is smooth to an extent. A computer's smooth. Like my t-shirt is not very smooth, so it's not going to have as high smoothness. So you want it to be as simple as a slider, so you define how sort of smooth an object is. However, let me plug that color back in. So we've got our color. So we've got Evan just sitting there like that. However, what we wanted to do is we wanted to people not only to define how smooth a whole object is, you could define areas that are smooth or areas that are metallic. So for example, with Evan, he has kind of like his rib cage. So his rib cage is kind of a series of tubes. So we want that section to be more metallic than, say, the rest of his body. So what we have here is we have a metallic smooth map using the red channel. And basically the lighter areas of this map is basically the more metallic areas, whereas darker areas aren't as metallic. So what I can do is I can actually select Evan, and I can drop in metallicness. He now has kind of more metallic, you see on his ribcage, and not as much elsewhere. So let's keep building him up. He also has a normal map, which is pretty standard. So let's drop in the normal map. So you can see that he's kind of got lots of like highlights and indents, which is really, really nice. He also has an occlusion map. So this is basically defining darker areas. So rather than using Unity's lighting to define the darkness around here, which is actually really bad for performance, so you're going to have to look at Evan, the lighting's going to have to look at Evan and work out every single indent. You can actually apply your own ambient occlusion map into the standard shader to define, oh, Evan's ribcage is going to be dark around here, or he's going to have shadows around his armpits, or he's going to have like a mustache, a darker mustache or something like that. He doesn't actually have a mustache, although I should probably add mustache physics. You can probably do that in Unity. So I can add an occlusion map, so he's like really nice. I can actually define how much the occlusion map, so you can see no occlusion, and then as I add more, he's then got the darker areas. This is my next favorite bit, emission. So you can actually define areas on your object that has glowing emissive areas. So if I was a 3D model, I'd have like glowing red eyes coming out. Whereas with Evan, where is it? It's there somewhere. Okay, so he's got glowing white areas. So we define them as white, so we can tint them to be red, pink, green, yellow, blue, white. Not black, because that doesn't really work. You can't really have a black light. Well, I guess you can. So I can then plug in emission, like so. And someone give me a color, any color. Not green. I thought someone was going to say white after I said no white. So I go to green. You'll notice that he has... let's have a look at his arm. We can actually we can actually define. So we could actually animate his like hands glowing. So if we keep ramping it up, it actually bleeds because that's about 50, and that's kind of bad. Whereas we can actually define. Let's have about there. So we now have Evan as one material with metallic areas, emissive areas, normal maps. We can put all sorts of other things in. We could actually apply something to a secondary map to, let's say we wanted him to have like a secondary normal map to make him look like he's chipped, like wood, or like he's like a rock surface or something like that. It's really up to you. But we have Evan. Now, the nice thing about Evan is he's also really optimized. That's one material, so that's one pass to the renderer. So for an iPhone 4, it's typically 40 draw calls or so, 40 things being drawn. I could have 40 of this character running around on an iPhone 4. So it's both really optimized, but also customizable for you to add and plug in values and things like that. Everyone happy with that so far? You're all very quiet.
We want a t-shirt.
You want a t-shirt? The cameraman's going to get all the answers because he has the whole presentation. So yeah, hopefully I can take part. Cool, so we have Evan. Beautiful. So let's have a look at our environment. So what we have here is with our environment, if I look inside, the GI is basically kicked in. And a couple of reasons has happened why. Firstly, we're using a skybox, and we're using an ambient light source from that skybox. So the skybox is blue, so everything in the environment is going to be blue. So let's say you had a skybox that was in the middle of the day, and you changed that skybox to nighttime, everything would then fade along with that skybox. So you're kind of using one big global color. Now, I'm going to, because this is an outdoor scene, and it doesn't really fit, I'm actually going to just take away that skybox completely, and you'll notice the GI is automatically updated. And we can look inside this environment here, and it's very blue, and that's because of the roof. Let's set the ambient color down, and let's set that off. So what we have here is inside this environment, you'll notice it's very blue. Can anyone guess why? Brilliant. So as write it down. So as well as having the skybox emitting like a global illumination, we didn't want to create a global illumination system which is only for outdoor scenes. We wanted people to be able to make the most of illumination and make the most of bounce lighting indoor scenes as well. Because like if you think with Unity games, if I go into the showcase, which I was having a look at, quite a lot of these games, like this game is sort of outside, the game in the top left-hand corner, Crossy Road is outside. Whereas this game, where you play as a loaf of bread trying to get to a toaster, like I said, you can make anything you want with Unity, is all inside. So it doesn't make sense to use like outdoor lighting for an inside scene. You want to use inside sea lighting for an inside scene. It really depends what you want to use. Pamela is a beautiful kind of outdoor game as well. So what we have here is we can use either Unity lights, so place point lights and place lighting within the Unity scene, or we can actually use emissive materials. So if I turn off this light, so what we have here is this whole scene is actually being lit by a texture, which is really, really weird, because this texture, like Evan has the green areas on him, has an emission of blue with a power of 43. So basically what we can do is on mobile games, if you're targeting really low-end platforms, you can actually just scrap all lighting and use textures to light your whole game. So one technique is actually having like a big square with like a light or with a high emission, and it kind of floods your game, kind of like a football floodlights, and then just hide that square from being visible. That's a really sneaky, cheap mobile technique if you want really nice lighting. But of course I can set this to be, because my GI is already calculated in my environment, someone give me a color, any color. Blue, come on. White. Actually, yeah, that white actually kind of works. We can also increase this emission, so we can decrease it as well. So, hang on. So let's say 0. Yeah, so it's black. And we can actually power it up. So we can actually see that this texture is actually emitting light into the environment and basically flooding the environment, looking like so. We can see it's highlighting all around there. However, white is boring. Someone give me a color not blue or white. Pink. Okay, you said pink. Oh, black? Yeah, that doesn't work. Black lighting doesn't exist. Okay, so this whole environment is being lit by one texture. Now that's good, but it doesn't really give you much control over this. This is a very static object. So what we can do is we can combine like real-time lighting with, let's say, if I go to add in a point light into Unity. Oh, it's in the wrong place. Position it like so. If we fly in. So we have the sort of pink lighting. So you can see with this character here, we have the pink lighting coming from above the surface. We also have this white light in the middle, which we can then tone up. So if I then increase the real-time light. So if I place the white light on the floor, we can actually see we have a nice sort of pink hue from the top surface coming down, but we also have this white light sort of affecting all the environment down the bottom, like so. And let's actually take Evan now. So where is Evan? There he is, cool. So you can see actually Evan, because he's outside of the dome, he's actually just being lit by his emissive materials, because you no longer have a skylight. So that's actually pretty cool. I didn't expect that to happen. Honestly, I didn't. So if I then, let's say, position Evan in the middle of the room, because eventually he's going to be running around kicking loads of cubes. And we now have Evan standing on the floor. And let's rotate him to him as well. Okay, that light is a bit too powerful. Let's tone that down. Okay, cool. So we've got a very simple scene. It's very dark, but it's being lit up by pink lights at the top and white lights in the middle. Now, one problem with that this may have is you kind of have multiple light sources. You could have a skybox, and then you could have like a texture light, and then you could have like a point light, and Evan's got green lights. So one really nice thing that our developers decided to do is you can actually view Unity in different types of ways to see what actually the light is being used. So if I go to the top of the scene view, you'll notice that we have different types of shading, different types of shadows. But if I go down to the bottom, we've got all the GI being used in the scene. So UV charts is basically looking at all the UV maps in our environment. Mostly you want them to be relatively white. That's actually a pretty good scene, whereas some areas it's not. I think that's purposely left in to point out what's bad. So open this up, and if your UV texturing or your artist is skilled enough, your UV should be really, really nice. If I look at albedo, you can actually see what the main color is. You can see with this character, that actually looks really creepy. Okay, so you can see with this character is mostly white, so the albedo is going to be white. So you can see also here at the bottom, We've got these sort of like plants. We've got these yellow curtains. So you can actually view what the textures are like. So she's got a really nice sort of like reflective headrest at the top. You can view what the environment's going to be like with no lighting whatsoever and no sort of texture detail. This is the one I like, emissive. So you can actually see what in our scene is emissive. So in this case, the big roof. So we can actually see what's affecting it. And then this was the one I like, irradiance. So what radiance is going to do is it's going to show how the lighting, it kind of removes all textures and moves all details and shows how the lighting is actually impacting the scene. So you can actually see from this pink light and this light in the center that the GI is not bouncing inside here. You couldn't do this Unity 4 because you'd have a light and it basically would like flood through all like different environments. It wouldn't be really nice. Whereas you'll notice here that just from this texture, it's pointing down, it's coming down to here, it's then bouncing around inside here, but it's not actually getting into this sort of dark corridor down here. However, it is bouncing around there. And can anyone tell me why it would bounce on certain materials but not on other materials?
Reflection.
Yes. So you know I showed you the smoothness to show how smooth the object is. That's where the bounce comes from. So if an object's really, really smooth, say for example, the floor, what's really smooth? Oh, you see the glass on the windows? That's really smooth. So lighting is going to hit it and then bounce right off. And that's kind of what's happening here. Because this floor is, if I go into here, because this floor, if I select it, is, it should be very smooth. So because the floor is quite smooth, it's basically then bouncing the pink lighting into this environment. And you can kind of see that if I go into a radiance view. Thank you for whoever picked pink. If I then select that light. So what you'll notice is that as I increase the emission, okay, so you can kind of see like emission, and then as more emission, you can see it's actually bouncing a bit more here. As I ramp it up, it's basically bouncing a bit more. If I set that to be green, you can see the emissive material is now bouncing all inside here. So that's kind of like, I'm going to leave it to be green for the time being, although that looks blue. Okay, that seems... Okay, that's fine. I'm happy with that. So we have a nice green environment. Now, there's another issue here. And so we have our lighting, basically coming from a texture, from a point light. We don't use a skybox, but you could use a skybox. We also have our character. This other issue is reflections. So what we actually have now in Unity is you can place points of reflections, where what it will do is it will bake the environment around it and apply reflections onto everything in that environment. Now, funnily enough, I think our graphics programs found out baking a reflection is actually the most complex and memory-intensive thing you can possibly do in any form of development. Because what it's got to do is a real-time reflection probe has to take a photo, 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 then wrap those photos in a ball, and then apply them to everything. And then on the next frame, take a photo, take a photo. It's got to do that every single frame, so it's really expensive. So what our developers decided to do with reflections in Unity is make them as customizable as possible, depending when you want it. So you can either bake it, you can kick off a bake via script, or you can have it real time. It's kind of scalable. So currently there's no reflections, so all what I can do is I can go to Game Object, Light, and here we can set up a reflection probe. And then what we can do is we can place this reflection probe in the environment. So reflection probe's currently sitting in the middle of this room. So what I can do is, let's say I set the reflection probe to be real time. Wow, okay, that's super intensive. So I probably need to tone down my light. Let's tone down the lights to about 10. Okay, cool. So if I select my reflection probe, you can actually see in my reflection probe the bake that it's just done. So you can see it's the real-time probe that it's just done. So you can see it's baking the lighting, it's baking everything in the environment. If I zoom out, you can now see that all the sort of like different highlights of the specular elements here. You can see the reflection of the floor, and you can actually see here in this object, which isn't anywhere near as kind of smooth as the floor, that it actually works out how smooth the object is and how it reflects. So here, this floor is very smooth from the texture, so it's got a lot of white highlights, whereas here it's very blurred. So you can actually see how the lighting and how the reflection is bouncing everywhere. So we have this probe in the middle of the room. However, that's not good enough. So can anyone tell me what this big box does? It's not Minecraft.
The radius of reflections.
Yeah, very, very close. You can have a free wristband. So what this does is it's almost like a bounding box where everything inside that box will use this reflection probe. So if you have a series of rooms, you place a series of reflection probes, and you can overlap them because they blend into one another. So if I have a character in one room that's got green lighting, and another room with red lighting, I can actually overlap these bounding boxes. So as my character runs from one room, the blending of the reflections is going to go from one to another. So I'm actually going to do that with my character here. So you'll notice we have the big bounding box, like so. We can actually tweak sort of how big this bounding box is. So if I go into my environments, basically if it's light, it means it's, so you can see it's, so let's say everything inside this box in this room here. Let's pull that back so we can actually see everything in here, like so. Let's pull everything back here, and then let's pull everything back here. So what we have now is we now have a bounding box just for our room in the middle of this environment. And you can actually see, if I look down here, you can actually see kind of, it's actually difficult to see, but you can see kind of the statue outline-ish. You can see the statue outline as well. So this isn't like a solution for screen space reflections. That's something our developers are working on, but you're able to place these probes. You can get pretty nice reflections down corridors and hallways and things. Now, I've got one big probe in the middle of this room reflecting the floor. So you think in, I always ask my friends who don't make games, what's the most impressive thing in a game? And they say something being reflected is apparently the most impressive thing in a game. So for example, you can imagine a player walking in and say, wow, I can see the green roof. Oh, wow, I can see it on the floor. This is super cool. I can shoot at it or whatever. So what we want to do is we actually want to have a probe in this room because you can see this with the lights. So on my screen, I can see here an outline of the statue being reflected in this corridor. And that's not too good. So what I want to do is I want to place a second probe just baking this whole corridor. So it's really easy to do. So if I take this probe, duplicate it, place it across, zoom into this corridor. So you can see that the probe is actually in the corridor. And you can actually see, like, do you see the lighting on the bottom left-hand corner or bottom right-hand corner? I can then sort of like, sort of define the corridor like so. Actually, that'll do. So what you should see here is we have one probe, which is bounding this box, another probe which is bounding this box. And if I view from the top, you can see that's sort of the one corridor, and if I go down, that's the other corridor. So they are basically overlapping. So what they'll do, so we have one sort of bounding area here, and then one bounding area here. So what will happen is if my character walks from here to here, the reflections will then follow along with him. So it looks quite nice. I'm kind of doing this very quick. How much time do I have left? Like 6 minutes? Okay. Okay, cool. So we have a super reflective room. We can even see the reflections in here. We've got two reflection probes being baked. Now, currently our reflection probes are real time. So this is good for sort of like desktop or console things, because what it's going to do is if anything happens in your game, it's going to keep baking it over and over again. However, we wanted to put in some fail-safes. So you can either bake it at the beginning, so when your character enters the scene, or like on the first instance of it, it then bakes everything, and then that's it. You could bake it every frame. I would not recommend using that because it's going to be very expensive unless you're aiming for your game to be on, you know, high-end supercomputers or something like that. Or you can bake it via scripting. So let's say in this room we have nice reflections. A statue falls over, and then a fire starts. What I could do is, as the statue's falling over, I could bake. When there's fire, bake it once and sort of blur it. So basically, you can actually kick off bakes via script. So you can define in your game when you want to bake it. If we didn't like that, we can actually use custom. So what custom does is you can actually interject your own reflections. So you could bake the environment, bring that into Photoshop, make it all cell shaded or blurry or something like that, and then bring that into Unity and kind of interject your own reflections at a point. So a lot of people tend to do that to have really stylized, nice games. Alternatively, if I set them to be baked, what they should do is they should bake the environment, but they haven't. Why have they not done that? Oh, okay, the reason being is because I select the atrium and I set not only light matte static, but reflection probe static. Yes. Okay, those should be big. Okay, it's not doing. Oh well. Okay, let's just stick with real time. That's pretty cool. So I've got my character. I don't think my character's... Actually, I'm going to change this roof. Someone give me a different color.
Red.
Red, sweet. That's really ominous, but fair enough. So you now got my character in this sort of like this environment. We've got sort of a baked area in here, and I could check like sort of like the sort of radiance in here. I can define sort of like how important that is, and I've got a couple of other areas. Now, a really cool thing that I can do as well is I can view the smoothness of areas. So like I was saying with the smoothness of the floor, is you see in this room, the white areas are the smoothest, whereas the black areas are not smooth at all. So you can see in this room, we've got the really smooth floor. Plants aren't really that smooth, whereas we have the smooth area in here. This dude's face is smooth, but like his bathrobe isn't. So you can basically see how smooth the objects are in your scene. Another really nice thing is you can see what the specularity color is. So this basically says, are they smooth and do they have a color? Are they golden or are they like of a red? So this glass is kind of like of a blue smoothness, so they'd all look blue. So you can see like this nice headrest here is gold. If I go back into my game, you can see it's got like sort of nice red reflections and highlight. We've got some really nice lighting, which is really, really cool. So what am I going to do now? So the next thing I'm going to do is show you some imported assets. So I'm going to save my scene. That's actually really important. Cool. So how many of you know about the standard assets that are in Unity 5 or Unity 4? There's jazz hands at the back. Yeah. So what our Learn team decided to do is they decided to create assets and create content that you can basically import into your Unity 5 scene. And basically these will get you to starting or get you to grips with, say, characters running around, 2D racing, a 3D car that drives around, a jet that even flies around if you want to make a flight simulator, as my granddad wants to do. Particle systems, so fire, smoke, water, rain, whatever, electric, environment, so like blocks and things like that, so you can block it out, and image effects. So this comes with every single build of Unity. So what you can do is you can go to Assets, Import Package. You can see here we have characters and we have effects. So I'm just going to import characters. So that's going to be all, basically it gives you all the scripts, all the models for a 3D character running around, first person character running around, and a ball that you can roll, which is kind of weird. So I'm going to import that. It should import it really quick. So that's actually the first loading bar that's popped up, and I've already got sort of like nice sort of like, yeah, light and stuff. Oh, this is awkward. Okay, cool, it's done. One thing I'm going to do is I'm going to actually turn up my lighting. Now, one thing I forgot to talk about is if I have my lighting and I turn on shadows, is how that real-time lighting works with shadows. So I've got my light, and I've got my light moving around in the scene. You can actually see with Evan is as I move my light around, the lighting is actually bending around him. So the reason why that lighting is bending around him is because the GI is already baked in how lighting and how shadows are going to affect onto the environment. So we have here our lights, which is being positioned all around here. I can lift that light up a bit. But a really cool thing that you can do is you can actually define the bounce intensity of every single light. So basically you can define how much that light bounces off of surfaces and bends around corners. So traditionally in Unity 4, you had to have about 400 lights in your scene for it to look good. And in this scene, you can kind of just have a texture light, and then you can basically have one light bouncing off of everything. So your games are already like really optimized because you don't have 500 lights. You can kind of have one light and it still looks pretty good. You don't even have to have a light. I could just set a skybox and use that to light my scene. So you want to go for customizable lighting, but also really nice and optimized and easy, because one light's easier than 500 lights, I guess. You're nodding, yeah. Cool. What it says here is current real-time indirect bounce lighting shadowing. So that means if a light bounces off this light and that causes a shadow and another shadow and intersecting, that doesn't currently work for this light, but it will do in the future, but it still looks pretty good. So we can define how much of this light actually bounces. So if this light doesn't bounce at all, you can see that our character, with this reflection on the bottom, has zero lighting. But you can see that as I increase it, we can actually see the lighting all sort of bouncing around in here. So if I look in here, we have sort of like, it's difficult to actually see, hang on. Okay, it's kind of difficult to see if you're not on my screen. Or maybe if I go left and right, you can actually see the reflection probes reflecting in the marble. You can see sort of like that section there. You can see sort of the doorway as well. But you can actually see that from that one light, it's actually coming in here, bouncing around here. It's lighting up this environment here. And basically the light, oh, wow, okay, that's super shiny. So basically what this light is doing is it's bouncing all around inside here. And I can actually view that in, if I go into Irradiance, I can actually view that sort of real-time bouncing that's taking place. So you can see it's bounced under here and gone into this alcove. Now this is one thing I really like to do in this environment. So currently our character just stands there. So what I want to do is I actually want to have a character running around. So what we have here is, if I tone down that bounce light and tone down the intensity, is when I imported those standard character assets, you can see down here, standard assets, we have characters, we have a roller ball. I could put a ball in there and roll him around and crush Evan if I want, but that's really, really bad. I could have a first-person character running around like a first-person shooter, like running around having a look around the scene, really easy. Or here I have a third-person character, which is what I want to do. And underneath here we have AI, which just walk around aimlessly around the environment. So that's kind of cool if you want NPC characters like, I don't know, Skyrim or Fallout or any other Obsidian game, or GTA. And here we have a third-person controller, which I can then bring in, and I've got a little boy. You can see like the reflectiveness as well. So you can see this little boy here is kind of like, that light is super, super shiny. Okay. We can see that this light here, this little boy here is basically positioned in the scene, and we can actually now run around in the environment. So if I then position my camera like so, so I've got my camera, align with view. So I've got my character, I can run around here. I can actually run through Evan. You can see that lighting, sort of like on the environment. I can actually run out here. I can actually run out that door. Whoop. Yeah. So for example, we have here. Whoop. Why did it do that? What did it do? It's funny, I have a theory that every time you do something in your bedroom 1,000 times or next to a grandma on a train, she doesn't care. You're doing all this cool stuff, doesn't care. When you do it in front of people who actually care, it breaks. So what I'm going to do now is file, save as, test one, load a different scene. Hooray, okay, cool, it worked. So yeah, turning it off and on again worked. Sweet. So now we have this character. We can have this character running around with all sort of like nice red lights. He walks down here. And you can actually see, weirdly enough, if I actually zoom in here, you can see the blue skybox. That's kind of tricky to see, but on my laptop, it's got the blue skybox actually reflecting on the floor here. So I actually have the skybox reflecting my environment somehow. Yeah, it's quite tricky to see. So, yep, it doesn't like it. Okay, that's fine. So one thing I really want to do now is I want to have my character Evan running around instead, because I don't want to use this little boy to run around. It's kind of weird. So what we have in Unity is an animator state machine that's actually been in Unity for like a couple of years now. Put your hand up if you know about the animator state machine that looks just like this. Oh, okay. So what we have here is we have a node-based system that allows you to transition one thing to another thing to another thing. So you can have a character. So in this case, we have our little boy grounded. If I run it, so you can say grounded is basically now playing through. He's standing. Whereas as soon as I jump, airborne is then going to play. So what you can actually do is you can actually play our animation going from one node to another node. So you can do this both for characters running around, but you can also do this for, say, like a UI panel sliding in, sliding out, a little 2D character running and jumping and things. Basically anything you want to animate in Unity. In this case, we've got this little boy. Now, the really cool thing about this is the animations you can actually rebind and put on another character. So our little boy is basically saying, when I push forward, go to his, say, like feet rig and his knee rig and things like that, and basically just animate. Now, what other character do I have that also has that same rig? Is basic. The white. No, that's horrible. Okay, cool. That's sort of sorted now. Okay, cool. So what we have here is we have our character. Let's tone down the lighting a little bit because it's kind of hard to see. So we have our character. So we have our character of Evan. So our Evan has basically got his one big material, but he's also got a whole skeleton of footsteps, his pelvis, his spine, his thighs, his legs, and things like that. Now what we also have is with Evan, or Ethan, for some reason all our characters are called E. I don't know why. It's probably a Danish thing. He has a body, he has glasses, but he also has, just like Evan, he also has a spine, he also has a leg, so he has exactly the same bone structure as Evan. So what do you reckon I'm going to do? I'm going to basically turn off everything to do with Ethan, so Ethan is no longer in my environment. Take everything from Evan, I should really name them something else, and relocate it under here. So we now have this third-person control, this whole animation system, but on Evan. And the last thing that we have to do is we have this whole state machine system. We then have to just say, instead of use the Ethan avatar, his skeleton, because Ethan's kind of thin, go and use the robot as well instead. So let's run that. Let's see what happens. Whee, okay. So we now have exactly the same animation, just drag and drop and just reassigned. And the really cool thing with the scene is if I go over here, because it's really dark, you can actually see his green emissive lights sort of like running around. And yes, he can walk out the door. Yeah. So we have exactly the same character and just rebinded. What's it doing? I apologize. Wait, okay, cool. So we have this character running and jumping. How much time do I have left? 1 minute minus 5 minutes? About 15, okay. So I'm going to show you one more thing. Well, 2 more features, maybe 3. Okay, I'll do 2 more. So as well as having all these visual tools to drop in, run around, have a character, rebinding, it's optimized. We also worked on physics, and we've also worked quite a lot on another visual tool. So I actually showed this visual tool to some people in Finland, and one guy started crying, and he had like tears down his eyes. He was like, this is the most beautiful thing I've ever seen. So I'm expecting tears in Serbia to beat the Finns. Cool. So what I'm going to do first is I'm going to have a bit of fun. So currently we have here this reflection probe in the middle of the room, and that's kind of boring. So I'm going to add a really simple script, which I've got called Spawner. Now on Spawner, I have a couple of things that I can set up. So on Spawner, I can set up what I'm going to spawn. In this case, it's a crate. So we have a nice glowing red crate, but I'm gonna turn down the glow to like 0. So we've got a really simple like crate. This crate has physics on it. So for example, when this crate's positioned in the scene, I can actually push it around. Yeah, I could actually have that crate glow as well. So let's do that. What's it doing? Okay, cool. So I've got this crate. What I'm now going to do is I'm going to go to my spawning script that I just added, set up this crate to spawn. Amount spawned every frame. How many should I spawn every single frame? 4. I did 400 at first, but okay. So what we're going to do now is, if I then make this maximize, I'm now going to have my stats window open, so we can see that I've constantly got, yeah, I've got loads of draw calls. So I've got like, for example, frame rate 80. Now if I then spawn, my frame rate didn't actually drop that much. So, and then I can actually have Evan actually running around in my environment. So every single one of these cubes is then has all the lighting bouncing on it, so you can actually see Evan like bouncing around. They're all reflecting the light in the top. So you basically have, hang on. Whoop, stop. Okay, cool, but like the frame rate didn't, it dropped down to 49 when I had probably about 100,000 cubes. So what we've actually worked on is the physics to actually be a lot nicer, a lot more forgiving. So rather than, if you did that in Unity 4, if you spawn about 10 cubes, it would probably drop to about 20 frames a second. In that, it was only when, okay, ignore this. Ignore these shenanigans. So whereas in Unity 5, we were able to spawn thousands, and they were all bouncing around. So one thing I did is I told the cubes to never actually settle. So if I say, look, this cube is not actually, oh, okay, it did settle. But if you notice, is that after I spawn some of them, they're all just going to keep bouncing around and sliding around. And we actually still have Evan kind of running around this environment. Yeah, he didn't die. Okay. Yeah, so we can actually have Evan running around this environment, not dead, and basically have all these cubes bouncing around. Now, yeah, so we have lots of physics. We need to fix that, but yeah, hang on. Okay. So one last feature, and then then I'll sort of go back to my slides, is this next thing called the frame debugger. So this was the thing that I basically showed to someone and they started crying. So that's all great that you have all these nice things and these new... Ignore this. So I'm going to start crying now. Yeah. Hey, I'll do this on the flight back home tomorrow and it will be perfect. So if I close down everything and I... don't maximize. Stop that. Close tab, window, frame debugger. Nope. Okay. All right, I'll try it one more time. Hey, this is the first release. Give us a break. Okay, let's actually add it now. No, okay. Ignore that. You can all cry at home. It's fine. So basically, the purpose of the frame debugger is what it will do is it will take every single draw call happening in your game, and it will show it as a big long list. So it will show every single thing being drawn in your game in the order. So it will show, oh, drawing the geometry, then drawing the lighting, drawing the shadows, drawing post-processing effects, drawing the UI. So you actually have a big list of everything being drawn in your game and how expensive it is as well. So that's how badass, it was so badass it crashed Unity. So what that does, what that's really good in doing is, say for example, everything in your environment is like 4 draw calls or 4 like objects, but then all your lighting and shadows have been ramped right up and you have real-time probes. You can see the real-time probes actually using up quite a few draw calls, whereas everything else isn't so much. So it doesn't tell you how to optimize your game. It just tells you where you should probably be looking to optimize your game. So it's kind of like a really neat feature, but it does not, do not want, yeah. Let's try it one more time. No, okay, ignore it. What it actually looks, oh yeah, okay, so the power of the internet. So Unity frame debugger. Luckily we blog about this stuff. Oh, he's even done a GIF. So you can actually see here, for example, you have this big list and that as you step through, eventually it will then show the lighting and sort of like the environment. That's kind of a weird. So you can see here, we can actually see and view and toggle through all the different segments and see what's on each individual segment. If I scroll down, so you can actually see like individual frames, you can see kind of the reflections, see how complex things are, and happy frame debugging right at the very end. And I think all the posts were like, this is the coolest thing Unity's ever made, ever. Yeah. Yeah. Cool. So I've probably got about 10 minutes left, so I thought I'd show something else. So we have that frame debugger as well, so you can basically look to see how complex your lighting is, how complex your shading is, and things like that. Now, one tricky thing is, who makes 2D games here? 2D. So you're probably looking at this stuff like it's totally useless, right? So what you can actually do is you can actually use this lighting and use these emissive materials and use all these reflection probes on 2D stuff. It's completely fine. So what we wanted to do is not have, oh, we've got these nice lighting visuals on 3D, but 2D, you kind of don't get anything. You can actually have, say, all these reflective and have all these materials on 2D objects as well. That's completely fine. You can mix and match them. So that's totally okay. That's totally doable. However, we wanted to implement other areas for 2D, and this is partly with physics. So one tricky thing with 2D is kind of doing area-based physics. So let's say you want to emit an explosion from here, and then, for example, everything within a range is affected. So to do that by script, you have to go in, you have to get all the objects, find out what the influence of that emission is based on, or basically if you want to have, say, some wind, and then it pushes everything to wind. So what we decided to do is actually just make all this stuff out of the box with no script. So what we have here is we have an area effector. Now the area effector basically says when something is in this area, apply a magnitude of 5 to it in a particular direction. So as I now play this, oh, okay, so it shatters. So you can actually see everything is basically, when it goes into a zone, being pushed. And that's basically everything that has physics in it. So let's say you were doing a racing game and you drop like a banana skin, like in Mario Kart. You could basically have like a defined area that the person would skid out on, and you can apply a sprite to that. You could say, for example, have a side-on game and you fire something into wind and then wind pushes it in a certain direction. I actually had this on my screen like all day once, like on my second monitor. Everyone's just standing there looking at it because it's kind of euphoric. Yeah. So you can basically define a whole area that it pushes an object. Now, that's a continuous force, and it's in a particular direction. So this is a bit more fun. So what this is it's a series of circles that basically say when an asteroid comes within that range, pull it into that center point. So rather than it being like a continuous force in a direction, it's kind of like a point-based effector. Now, our 2D team make really kind of weird content. So what I thought I'd do is I'd play around with it a bit. So in this top area, we have this ring, and we have a gravity effector. So we can apply a minus force to it. So someone give me a number, any number. 7. I'm not asking 7. That's boring. Come on. 700. Okay. Okay, let's do 70 to begin with. So if I set it to be 70, in the top right-hand corner, you can see that they're all being pulled with that particular force into the top right-hand corner, a force of 70. Now, if I was to go to this and I said, instead of 70, I want to do positive 700, rather than attracting it to that point, it's now going to repulse it from this point. So you can see that as they come into the range, okay, the little bits are like particles, so it doesn't really do it. But you can see this one's like, nope, go away, go away, go away, and crash into that one. So you can basically not only attract, but also repel. So I think 7,000 is probably high enough. So the top right-hand corner. Goodbye. Yep. Bye. Bye. Yeah. So you can basically shoot everything away from that point. As well as having this, you can also change this on runtime. So we have here a nice little magnet. This nice little magnet has basically an area that's going to pull everything to. And now what we can do is we can actually have coins then pulling up to this magnet without any code. So that's pretty cool. And then we can basically then send them away. So now coins will now like rumble and sort of fade away from here. So you can see these are they're kind of scared in the corner. I showed this in a school, and this girl was like, they're so cute, leave them alone. Or I can pull them all in. So they're all now going to like, yeah, rumble and pull in. So that's without any code. I'm having all this sort of physicsy fun. Now the last one is, I like to sort of end the presentation on this, is just like any company, we made a Flappy Bird clone, but in this time we decided to blow up Flappy Bird. Yeah. So what you can then do is instead of having it as a continuous force, you can kind of use it as a one-shot and go poof. So with this bomb, let's play around with it. So if I go into the bomb, I go into the effector. So we can say apply a force of 500. So what this is going to do now is yeah, goodbye. Or what we can do is we can stack them up like, this is my thoughts on Flappy Bird. No, I don't show this one. I think I show, yeah, something else. But what we can also do is, as well as having that, we can not only apply things being emitted away, we can actually apply things being sort of sucked into one point. So rather than emitting it away, we can actually pull everything into one point. So there we kind of create a black hole. Hang on. Because what's happening is every time a bomb's happening, it's like pulling it all in.
Just to say, it's about another
3
3 minutes.
minutes. Holy smokes. Oh yeah, okay. So what you can do is not only have continuous forces, either attracting, repelling, or pushing in a direction, but also emit these things. So let's say the first one I could have, when something happens, it pushes everything in one direction or the other way. So yeah, like these physics, we wanted to make really easy to do things that were originally quite complicated in something like Flash or PopCD or whatever it may be. Right, so let's go to my slides. So we have physically based shading. So we have this demo, the Viking village. We have that environment, the scene I had with the statues and things like that, and the characters running around. That's all on our asset store, so you can actually download all that for free and play around with it. So everything I did, you can just go to our asset store, download for free, take it apart, use it in your games, whatever you want. It's pretty cool. We also have this doll character, which is in there as well, which is very beautiful, and you can, that's all being rendered in Unity, which is really nice. Reflection probes as well, so you have this weird robot, and you can see reflective surfaces on the floor. Enlighten as well, which is basically, our whole GI system is based on Enlighten, which is used in Battlefield and Mirror's Edge and all sorts of things like that, so it's really shiny, in your hands for free, which is pretty cool. We also have an audio mixer. Now, the reason why I didn't show this is because this takes a long while. You're smiling, so you've probably used it, right? So the audio mixer actually allows you to mix different audio and change pitches all live, and you can have, say, when something fades in, it tones down different audio tracks. So previously in Unity, audio mixing was play, pause, and stop. And now you can actually have echoes and do all sorts of really nice sort of like audio effects. Whenever I show this to audio people, they start crying as well. So everyone's crying at the end. 2D physics as well, which is pretty sweet. So I guess for the first version of Unity 5.0, we have whole new rendering, whole new lighting, whole new audio, whole new 2D physics. You can export to WebGL and eventually be able to export to new 3DS. Whole new UI system for creating UI panels in your game that could have emissive materials and surfaces. Dual core debugger, which unfortunately didn't work, but everyone can go home and like play with it and cry. iOS 8 Metal support, you just click a button and it works. 64-bit editor, so you can have more stuff in your scene. Physics update, so physics is now super optimized and really, really nice. You can now have nice, pretty trees. There's lots of sort of animator updates, and in our release notes, thousands of other improvements. So our release notes for all of this is like, I think like 27 pages, 28 pages. And there's loads of GIFs of really weird people, like people animating and smiling, and it's very odd, like all of the GIFs that we have in like the release notes. And yeah, so I have 1 minute left, so I'll go through this next 1 minute. Yeah. Okay.
So time for some questions.
Yeah, time for some questions. So I'll do this next bit in 30 seconds and then 30 seconds of questions. So that's all the stuff to make games. So what we've historically done is only done sort of the bits in black. So you helped, well, we haven't done that. We've helped you to make games and helped you to release games on by having partnerships with Nintendo, Microsoft, Sony, Intel, Facebook, Oculus, Qualcomm, BlackBerry, all these people. We haven't actually done the other things, which is actually the bulk of development. Like I was talking to a guy from Sega, and he released Sonic Dash on an iPad, and he said he worked more on the game after it was released than before it was released, which is a very weird thing to go into because you have to update it, you have to add more, you have to add a Christmas update, you have to add more content, you have to fix stuff that your players don't like, you have to add new characters. So actually all these red things, we've actually built services. So it allows you to, with cloud builds, you can build your game in the cloud and then distribute it to target devices, distribute it to anyone in the world. Like I could send it to people in Australia if I wanted to, like via a push of a button. We also have like built-in analytics. So people don't actually like integrating analytics. So we actually do that bit for you. So you can actually see, is my game doing well in Germany as opposed to France? Are iOS users actually enjoying my game? You can set up custom events. So number of times Flappy Bird was blown up. Now I can track the analytic data from that straight away. Online exposure. So you can now in Unity do things such as start recording, stop recording, and share recording. So you can record what the game is seeing in their webcam or if they give permission. So if they're doing a horror game, like the Oculus Rift, you can see them running around the corner. I can send it to my mum, and she's playing the game, starts recording. She gets a jump scare, she starts crying or whatever, stops recording, and then she can share it on Facebook with all her friends. So you can have people like YouTubers and any reviewers basically playing and sharing your games. So it's almost like free marketing, which is really nice, which is what they do with Crossy Road. And we also have video ads basically integrated to make money. And that's kind of what Crossy Road did. They used kind of a bit of everything, and they made millions, and it's like 2 people. So that's basically everything I said. And yeah, that's kind of our goal. Our goal is to help you to create awesome games, help you to basically deploy it to as many 23 platforms, connect with basically everyone. So you can make great games, connect with everyone, have them sharing, talking about your game via social media and everything. And then basically succeed as a developer by having loads of downloads, loads of people playing your game, and then put a roof over your head and stuff. So yeah, make great, awesome, kick-ass games. And that's basically it. I know I've rambled kind of a bit and played around with it, and there's some technical difficulties. I hope that was okay, or people were interested in that, or they're going to go home and rinse their Wi-Fi and download everything now. please do. And if you use any of it, if you have, say, that environment or say that character running around and I don't know, he's like in a horror game, please send that to us because we like to see when people use our assets for their own games. There's mostly horror characters, which is kind of weird. I'll be around for the rest of the evening and... okay, so I'm around now. Yeah, sure. So I can answer questions now or just come up to me or send me an email or a tweet, whatever it may be. Oh, hi.
Hi. I want to ask, when or is there a plan to make visual-based shader editors for next work?
Yes. So, for example, the standard shader that we have is kind of like, we wanted to put that in place because we wanted people to then drag and drop in textures that can define it. So you can actually make things look nice out of the box straight away, and more complex than you could in Unity 4, straight out of the box. And we do have plans for that. We've just got to get around to doing it. So we do have plans for it, but those plans are kind of in the long run. So what typically happens in Unity is we have a big list of 1,000 things we want to do, but only the time to do some of them now. And we do have plans for that sort of thing. We do have a video on our YouTube where we have a big conference in America called Unite. And we're also having one in Amsterdam in June as well, where we have a wish list talk, where basically we get a list of all the things the community asks, and then all of our developers, like our CTO, the lead of animation and things like that, actually address and talk about the status of these things. So that's all on YouTube if you want to see how, like, yeah. So we want to get there eventually, but yeah, so yeah. Does that answer your question, hopefully?
Yes.
Yes, yeah. But it would be very nice. It wouldn't be, so currently that was Unity 5.0, and we have 5.1, 5.2, and so on and so forth planned. So like 5.1's got a whole brand new multiplayer networking system, so it's very easy to set up multiplayer networking games, which is really, really cool. Like drag and drop easy, that's pretty sweet. And a whole bunch of integrated VR that Oculus are putting into it and things like that.
When will the next multiplayer?
Soon. Yeah, we don't have dates because the development's unpredictable, but we're posting loads of content on our blog about it now, so yeah. Yeah, soon. So yeah. So hopefully in the future. Cool.
This time this year.
I can come back and show it.
What about the vectors for particles? Like you have in 2 dimensions, you have it in 3 dimensions for particles, force effectors.
So those force effectors.
And if you repeat the questions,
Oh yeah. So the question is, so those 2D force effectors. What about for 3D particles? Is that right?
Have something in plan for that.
I think those 2D effectors do actually also work with 3D particles, because 3D particles, I think you can now define. I'm saying I think. I need to double check, which I'll do in a sec. I think you can now define 3D particles. Originally, they had 3D collisions. I think you can now define them as 2D collisions in which they will affect in there. So it should be possible, but I need to double check that. So yeah, if not, then I can always like pass it on to our development team, and then basically they'll say, okay. That tends to be what happens.
I know it's on your list for a long time, nested prefabs.
So yeah, again, that's also on our list. Oh, the question was nested prefabs. When is that happening? So that is also on our list. So on our list is like the shader editor and nested prefabs and a couple of other bits and pieces. That's also like plans, but when we work on these things, we'd rather not just rush out the first idea that comes into our heads. We'd rather work on them and make sure when they release they're right. Because if we rush something super quickly and it's horrible, we've then got to remake it. So it's twice as much time. So with the UI system, that took a while to make. Like our UI developers had to make something that worked on every screen size, every type of input from mouse to finger swiping to controller to Oculus to all sorts of things. It's optimized and people can do whatever they want with it. So like, can you imagine having that task? So you have to make a system that works for everything, basically. So they wanted to, when they worked on it and released it, it was right to release it. And the same with nested prefabs. There's, I think, in that video, like I was saying, if you go and type in YouTube Unity wish list or roadmap, they say there's, I think our CTO talks about 4 different ways, or 3 different ways, or 2 different ways they could do it and how they would execute on that. It's just kind of like finding the right one that when we release it, both beginners can understand it, but also people who've been using Unity since like Unity 0.7 or whatever, when it wasn't even called Unity, I don't think. Basically it works for everyone. So yeah, it's kind of making the right decision, because if we do it badly, we then got to remake it from scratch. Like, I think it was Miyamoto that said, like, a rushed game could always be bad, but a delayed and thought about game could always be good.
Will eventually be.
Yeah, will eventually be good. Yeah, so something like that. So it's kind of the same theory, I guess. Yeah, we don't release something that's bad. Yeah.
One more question.
Okay.
Yeah. What about the WebGL? When it's coming out of beta, when it's going to be ready? Usable.
Usable?
More usable.
More. What do you mean by more usable?
I don't know. Still, it's preview, so I don't count it.
So the reason why it's preview is... Oh, sorry. So the question was, WebGL, when will it be more usable? I think it is usable now. The only reason why it says preview is because it's not the 100% feature set of Unity. There's a couple of things in Unity that don't, I think, work out of the box necessarily. So let's say Oculus support, or I think like external controller. And I think there was a list of basically things, so like movie files, but I think that's now removed. So we released it as preview because it's not 100%.
Scares me.
Well, my advice is to try it. Like yeah. So the preview there, we have a list on our website. So if you type Unity WebGL blog, we have a list of things, but that list is slowly coming down. And we're working with all the major browser providers. So like with Apple, Google, Microsoft,
It doesn't work in Internet Explorer at all.
It does anything. So I think it works in. Sorry if you work at Microsoft and you're here, by the way. Oh, cool, hi. I think it does work in IE 11?
At least it didn't work. I checked it like 3 weeks ago.
I think it works in Project Spartan, like their new browser. Like it should work in a version of Internet Explorer, I think. But we've been working closely with Mozilla for like Firefox, Apple Safari, Google Chrome, and then like Microsoft Internet Explorer, and I think Project Spartan or whatever. Basically any WebGL friendly browser. But it's tricky because we want to push WebGL loads, but we have to wait until other browsers get good enough to be of the same quality as our web player. So our web player, we're still going to support. We're still going to have the web player as an option, but we're going to have both web player for old browsers and WebGL for new browsers, kind of at the same time. And I think what some companies do is they actually build their same game in WebPlayer and WebGL. So they just build it to 2, and then just write some HTML or JavaScript or whatever to basically say, if you come to this browser, what browser are you using? Is it WebGL friendly? If not, redirect it to the plugin, and it's all okay. So I think the web player is automatically installed in browsers in China, Japan, and I think Russia, maybe. So yeah, like there's a lot of 600 million downloads of it, but we want WebGL to get there. We just kind of have to work on it more. So that's why preview's there. But eventually, like, we do see the future of gaming in the web to be in WebGL. So that's why we have a full team working on it and working with all the people who create the, I guess, the hardware or whatever it is, the software for WebGL to, it's quite different. They had WebGL working from Unity 3 years ago, and it was just a cube spinning, and then it's come on quite a bit since then. It's always a cube spinning. They tend to do that with everything. I think they did that with the Nintendo 3DS, or the new Nintendo New 3DS, a cube spinning.
Just one question, one of the other guys been asking that, I can ask after.
Excuse me, if I can interject, we should stop now, if you don't mind, Andy. Is that okay with you?
It's not okay, but yeah, that's fine. I'm joking.
You're there with us, isn't it?
Yeah. So thanks for coming along. Thanks for watching. Thanks for any technical issues. It wouldn't be a tech presentation without technical issues, of course. And yeah, thanks for coming along. Thanks, Milan, as well. I remember meeting you at Casual Connect Belgrade, and you were interested, and this is what you've made, my friend. And now you're on camera. So yeah,
Ladies and gentlemen.
and thank you. So cheers.
Hi, my name is Nikola. I'm a game developer from Cofa Games. If you never heard about us, we are currently developing a multiplayer game called Awakening of Heroes. It's a 5 versus 5 real-time combat game. It's cross-platform. It's developed in Unity. We're using Unity for entire game, except for networking stuff. But the two interfaces are very similar. We use something else, but it's quite similar. Okay, I'll be quick. So this talk will be about networking with Unity, or building a network-based games with Unity. So, and it will target an audience that already have some experience with Unity game engine, but don't have experience building any kind of network-based games. So let's start. When we want to create any kind of multiplayer game, basically we have the common two architectures are peer-to-peer architecture and client-server architecture. In peer-to-peer architecture, the clients are represented as those peers that we see, and they all communicate with each other. And we also have a client-server architecture where we have some centralized system server, and the clients are all connected through that server, and they all communicate through that server. With Unity, I think that most games are built with client-server architecture. We also use that architecture with our game. Peer-to-peer architecture it's really hard to synchronize all players. Also, it's hard for new players to join an existing game. So, and I think that it is used much nowadays. So when we talk about client-server architecture, basically we have two approaches or two structures: non-authoritative server and authoritative server. We, for our game, used both approaches. Actually, we started as a single-player game, then we transferred it to multiplayer, then we created it to be a non-authoritative way, and we actually simulated it to be kind of a peer-to-peer, so to speak. But later, and now we use an authoritative server architecture. Now we will see what is that. So first architecture is non-authoritative. All the game rules, the game is played locally on the clients, and then the clients update the server, and server update other clients, and so on. And that worked for us to some point. We had very smooth gameplay because everything happened in an instant. Also, our server did not do very much computations. Bandwidth was not too high, so it was good. But we were very, very hard cheated. The kids, 10 years old, just downloaded cheat engine, looked at some tutorial online, and just cheated us. And they, it's really easy to cheat, and everybody can learn. We also had some bad behaviors. If some player have a lag or network or connection problem, he won't be in sync with others, so we can experience really bad examples. I would say that it's results well, but we needed to move to another approach, mostly because of cheatings and bad experiences. Then we decided to switch to authoritative server, and the idea is that we have that centralized system server that is responsible for every calculations for every game update, every game rules, logics happened on the server, and the clients just send a request to the server, and then server will update clients. It's just like watching a movie. We were very hard to cheat. No one cheated us since we transferred to this architecture. Game was much more accurate because every client, every player got their game state from one source, and it's good. But the game suddenly seemed less smooth because it really takes time to send a request, then server will perform some operations, then the server will update all the clients, so and only then we will see what really happens. So it really impacts the smoothness. Also, our server was overloaded with bandwidth, with computations. We couldn't spawn many game servers like before. Hoću kažem da nas je dobre stvari sa autoritetnim serverom su pobedile loše stvari, tako da u svakom slučaju nam je ovo mnogo bolje. Okay, so now we will go through some of the main components that Unity offers and go through some of the Unity API for networking. Unity have a network class that is real heart of their networking API. So here are the examples of how would you spawn a server. So you need to call the initialize server. It's a static method. You need to specify how much connections the server can handle. You need also to specify the port on which server we listen to, and whether we want to use a net punch through, which is a technique basically to connect to a server that don't have a public address. Also, it's really easy to connect to a client. You just call the connect function, specify a IP address and port, and that's it. In reality, it can be complicated depending on your server, whether it has a public IP address or a private, firewall problems, and so on. Unity also offers us messages, so we know when server is initialized, Unity will call these messages. So we know when player is connected. We can use that if we want to spawn a character for player, or I don't know. We can use a message on when player is disconnected. Also, we have a callbacks on the client side, so we know when we are actually connected or where we fail to connect. Maybe we want to automatically try to connect that player back again. So that was about spawning the server and connecting a server and a client. Okay, for communication, Unity implements two basic approaches. So it's you can communicate via remote procedure calls, and it's also called RPC, or with state synchronization. To do that, any game object that wants to use a communication to communicate with other game objects need to have a network queue component, and we can set up whether we want to use a RPC or state synchronization, what we want to synchronize, or we can use both. So RPC is a way in which we call some method over the network, and we invoke that method, and we use RPCs to invoke a commonly not that frequent action. So if I want to somewhere in the game open some door, I would send a RPC call to the server, and server will open the door for me. This is how would you specify a RPC method. So you need to specify the RPC attribute, so the Unity knows that it's an RPC and to know that we want to invoke that. The function can be private or public, depends on how we would use it locally. Unity uses a reflection to actually invoke this method. For parameters to RPCs, we cannot use everything. I think I have on the slide, next slide, what we can use. And on the bottom, we can see how we can invoke that RPC. So we have the network queue component, and it has a RPC method. We need to specify what method we want to evoke. We need to specify a method, RPC mode, and also we can pass some parameters whether or not that function we want to invoke has parameters or no. So RPC mode, it's very important stuff. So in authoritative server, we want to send messages only to a server. So we basically always will use an RPC mode server. Then the server will update the game state and update the clients using an RPC mode others or all. We can also call a buffered RPCs. It's just like normal RPCs, but they are stored in the buffer. And actually every client that connects to an existing game will receive those buffered RPCs and invoke whatever we had in that buffer. So if we want to reconnect some player played some game and disconnected, we want to reconnect it back to the game. If we had some buffered RPCs, he will get that all. So he would be updated with the game. For parameters, we can use a basic value types, ints, floats, strings, basic Unity types, vector trees, quaternions, network queue component, network queue ID. That's the unique ID in which Unity use that ID to identify different game objects on the network. Also, we can pass a network player, and network player is a structure that represents us as a client. It has our port and IP address and so on. The other way of communication is as state synchronization. It's used for data that is constantly changing. Most commonly is for a character's position. So if you want to synchronize character's position with other clients, we want to use a state synchronization. So the character is always in sync on all clients. We also have two ways we can synchronize. We can synchronize our variables. So we can send an unreliable messages. We can send reliable messages. For character movement, we would almost always use an unreliable state synchronization because we don't need to know that our packets are actually sent because it probably will be overridden next frame. We can also use a reliable delta compressed synchronization. These are ordered packages, and also only the values that are changed will be synchronized. With state synchronization, we should take care of. We can create a network overload, so we can increase bandwidth. So we need to be careful what we are synchronizing. And we can do some things to actually improve that. And this will be an example of how would you, how we would synchronize custom variables. So here we want to synchronize our position. When we attach a network queue component to a game object, Unity will try to call this method if we enabled synchronization. So basically we ask if stream that are passed to this method is currently writing. We want to serialize whatever we want. This example is our position. And if stream is reading, we want to deserialize that and take whatever we received and set our position to that value. We can synchronize strings and integers, booleans, whatever we want. If we set it to unreliable synchronization, this will constantly be called. If we set it to be an reliable delta compressed, if we actually stand in place and our position don't change at all, we won't use this. We also, Unity also offers methods to instantiate game objects over network. It's basically pretty simple and it looks like basic Unity instantiations, and that method is based upon internally based upon RPCs and that are stored in the buffer. And what that means, if we play some game, we create some objects, suddenly we disconnect from the game. If we connect back to the game, those objects will be spawned again. So this is the way we instantiate an object. Instantiate is also a static method from network class. We need to specify a prefab, we transform position, we can additionally add a network group, and we also get a message when that object is instantiated. So whenever object is instantiated over network, we get this callback on network instantiated. We can use that for something like a start method or a wake method, very similar. However, I don't believe that this. Yes, we have a network destroy. We can destroy any object that is network created, but those calls are not based upon buffered RPC. So if we create some objects over the network, we destroy them, we disconnect from the game. When we connect back to the game, those objects won't be destroyed. So we need to handle that manually, and we can use that on callbacks when we disconnect from the game. We could delete those buffered RPCs and so on. This was the basic of what Unity offers us for networking API with synchronization, communication, with the network instantiate. We can basically create a simple network-based game. For large multiplayer games, it takes much more than just a server and client. Many more components are usually implemented. Most of those components are not Unity applications. And I think that's about it. So this was quick. Thank you for listening. If you have any questions.
Thank you. I would like to be the first to ask a question. First of all, many congratulations on your recent success with Awakening of Heroes. I mean, your game got greenlit in about less than a week, isn't it?
Yes, 2 weeks.
Well, that's a big applause for you. I would like to know in which way, if possible, Unity made an easier greenlighting process. So could you correlate?
What?
Could you correlate on that?
Well, Unity made it easy because it was very quick to adapt for for a Steam platform. We actually needed just to solve login problems and use Steam's API. And we are in process of doing that, but apart from that, I don't think any other changes needed to be done. So we just could port the game to Steam.
Thanks.
Yes.
Hi. How would you make a game lobby in theory, not the actual code? How would you know that the client is connected? His IP address? Do we need to port this?
You can use a Unity application, just like you can use those messages when player connects to the server. You can use that as a lobby, and that lobby can communicate with some other app or can spawn a game servers themselves. If that's what you're asking me. You can use the Unity application for that. You may not, depends. If you use a Unity networking, Unity has, I think, a master server, and he is responsible for that.
Yeah, that's my question about what about a lot of players? There is no database, username, passwords. How
you can specify the passwords. You can use a whatever kind of database you want. That's really different from Unity stuff. So we always have connection with database. It's very important to use a database. We actually have some lobby system. Part of that lobby system is Unity application, and we are also connected with that lobby. And he's responsible to pull some stuff from database and so on.
So basically, we have a master app, and master app is connected directly to, let's say, MySQL. So
our lobby is connected to MySQL, yes, via PHP or something.
Any other questions, everybody? Come on.
I have a question. So how did you test the game? So your game is...
It was very hard to test the game.
So your game now, is it 5 versus 5 or?
5 versus 5. Actually, it is very important to have at least one level when you can go and play game locally, so you can test your game features and whatever you implemented. So we have a debug mode in which we can test our heroes, our weapons, and so on. If you want to test it over network, we actually just ran 2 instances of a Unity. One is a server, one is a client. And we actually play 1 versus 1, or we have a bots. They are very helpful.
So you made yourself versus yourself?
Yes.
You're very good.
Yeah, I am.
When you said we have like a sandbox playground, sorry, I'm asking those questions. Sorry. So when you said you have like a sandbox,
it's a level, just
so
game level in which we can play the game without using any networking stuff.
So if you come up with a new attack or a new ability, you can then just test it in this kind of small environment?
Yes.
That's pretty cool.
Actually, I think we first implemented to work locally, and then we adapted to use it over network. Yeah. Thank you. I didn't hear that. I'm sorry.
Main server application.
Game server.
Yeah.
Okay.
Client application.
It's actually the same build, but we have a logically separated client and the server, but it's actually the same build. When we build a server, we just delete images and textures, and that's about it. So it's the one project. Oh, if that, yeah. Thanks.
Anybody else?
Okay.
Excuse me, I've got one more. Sorry. I'm very interested in all that, Steam thing you're up to. I mean, your game is to be soon released on Steam, isn't it?
Yes, I believe very so.
So how's that going to work? Do you know anything about that? I'm interested in how does the Steam thingy fit in your system?
Well, we just, I think we just started exploring the Steam API, and
So it's again about the API, yeah?
yeah, we need to implement some more features before we actually go to the Steam. So I don't know exact details about that.
Okay, yeah.
You can ask my colleagues.
Hi, colleagues. Have you got anything to show us about your game, maybe or something?
Yes.
So, Mr. Graham, do you truly believe that every single person can awaken the hero within?
Of course I do, dear Miss M. There will come a day when citizens in this town will finally reclaim the limitless potential. Streets will become an arena staging the ultimate fight for the awakening. But make no mistake, before the dawn of awakening descends upon us, many things must come to pass. They need to act as a team, to evolve crazy superpowers, to be unpredictable, to fight brave like lions.
Oh, sir, what a lovely little tale. I bet there's more. Come on, show me a way to the awakening.
Oh, my sleeping beauty, it's a long way to the awakening. No shortcuts. In that process, you would have to build your own town, collect power-ups, conquer all obstacles. Able to find the book of the awakening. Use its knowledge wisely, and you'll be ready to open the portal to the new world. Oh, my sweet Lucinda, where are you now? Where?
Ready to rumble!
Bravo.
Okay, thank you. That's it, thanks.
Okay, so questions are over, I think. Anybody else? Okay. So we should just say goodbye to Mr. Nikola Carija from Cofa Games.